Let's try to calculate or to compute the lengths, angles, and area of the following triangle. Since we know one angle and its opposite side and another angle, we can use sinus law that says that a side divided by the sine of the opposite angle is equal to other side, which is known 32, divided by the sine of the opposite angle. And then in this equation, we have only one unknown, b. So that's the way to compute b, the side b, the length of b. Then b is equal to 32 times sine of 55 degrees divided by sine of 15 degrees. Let's do it with an FX Casio calculator. Let's compute in this FX Casio calculator the fraction or quotient 32 times sine of 55 degrees. I know that this calculator is in degree mode, divided by sine of 15 degrees, and store it in a memory called B, capital B, because there is such a memory in this calculator. Then shift store in memory B. This is the answer. 101.27.873 is almost 101.28, but almost is not exactly 101.28, but I'm going to store it in B, 101.28, rounding, rounding. This is about 101.38, but don't lose any precision. Remember, we have this as exactly as the calculator can store in its memory, a better number than this one. Remember that our answer is an approximation, 101.28, but really we have it stored in our calculator in the B memory. This is the exact value for the calculator. Now, we actually know two angles and two sides. We remain to calculate an angle and one side. But this angle is easy to find because the interior angles of a triangle add to or summed 180 degrees. 180 degrees. So we know that 15 degrees plus 55 degrees plus this unknown angle is gonna give 180. So this is 70 plus gamma is 180. So gamma equal to 180 minus 70 is 110 degrees. This is 110 degrees. So as you can see, this picture is not exactly following the measures of the angles, because this is the bigger angle. This should be the bigger side, and it doesn't look like. Now that you have this, let's see the situation again. As we can see, the only value we don't know is C. But using the sinus law again, we can say C divided by the sine of the opposite angle is equal to D, which is 32, divided by the sine of the opposite angle. And then again we have C equal to 32 sine 101 degrees divided by the sine of 15 degrees. And then we have 32 sine 101 divided by sine 15 degrees equal to 129.37 approximately. It's an approximation. 121.37, you know. So this side is 129.37. And of course, it's the bigger side of the triangle because it is opposite to the bigger angle of the triangle. And we are finished using the sinus law to solve triangles. Not necessarily rectangular, any triangle, in some cases like this. Now to find the area of the triangle, go to page 805 of the Precalculus second edition book in OpenStax. And you will see the formula of the area is 1/2 of the product of two sides of the triangle, two known sides, times the sine of the angle whose sides are those known sides. You know, it says 1/2 of the product of the sides times the sine of the angle whose sides are A and B. A times B times the sine of this angle divided by 2. This is the area. Then, in our case, our area will be, we have to get two sides and the angle between those two sides. Like in this case, I can use B and D and the angle that they form, or B and C and the angle that they form. Anyway, this is not exactly the measure of this side, but I remember that I stored this result in the calculator. I have a result better than this. Then, using the formula for the area, I've said that the area is 1/2 of the product of two sides, which means this side, I'm going to write B, which is the name of my memory, times 32, which is the other side, times the sine of 101. And this is the value of the area. Then, here it is. 1/2 times 101.28, but I prefer dB, which is the value that is stored in the calculator. Alpha B times the other side, that is 32 times the sine of the angle between B and D. This is times 32 times the sine 101 And you got the right answer for the area. See that? 1590.69, rounding. This is the area of this triangle. You can choose any size. For example, you can use A equal to 1/2 the product of those two sides, 121.37 times B times the sine of 15, which is the angle between those two sides. And we give you 1/2, which is 0.5 times 129.37 times alpha, because it is in a memory, alpha B times sine of 15 degrees, and you got the answer. See the difference? Check the difference. About 73. Why is the difference? Remember, the reason for the difference is this number is exactly 32. This number is the best approximation to the measure B, which is stored in the calculator. So this is a good answer, because this one has the problem that instead of having the same value B, which is a good value for this side B, instead of the 32, you use this number that is not exactly, because was the result of a calculation, of calculus, of calculating, was not given. This is not exactly. Then, since I'm not sure of this number, this is an approximation, this will be an approximation, and this is also, but instead of this number, I have this number 32, which is exactly the number. It's exactly the measure of this side. This is not exactly the measure of this side. See the difference of the same problem with the same kind of formula using different size. Try to don't use in calculations numbers that have been affected by errors, because using computers, using calculators, you only get approximated values to some numbers.